Let's start with a simple observation. When temperatures drop below freezing, water turns into ice. This makes perfect sense, and we see evidence of it happening in puddles of water, ponds, and even ice cubes in the freezer. But we're missing an important fact if we assume that water simply turns to ice at 32 degrees. It turns out that the formation of ice crystals is an extraordinarily complex and delicate process that involves the stacking of water molecules in precise geometric layers. This stacking of water molecules requires either extremely cold temperatures at negative 30 to negative 40 degrees Fahrenheit or highly stable conditions, which is why we see water freezing in puddles of water or ice cubes in your freezer. But the reality is that water molecules are rarely stable in nature. So think about rivers, think about falling rain, think about clouds building up in a storm, yet somehow, as if by miracle, trillions of snowflakes fall from the turbulent sky every winter. So, if ice crystals require stable conditions, yet they somehow form in turbulent clouds, there must be something else going on, and that's exactly what's happening. The answer is not only one of nature's greatest mysteries, but also one of the reasons why life exists on planet Earth. It turns out that another part of the story is that water molecules floating in the air don't just start sticking to each other to form ice crystals. They need a starting point. And these starting points are airborne particles called condensation nuclei. These floating particles can be bits of dust, clay, soot, pollen, spores, organic matter, or even human-made pollutants. And in every case, they provide a platform that attracts water molecules. And as soon as water molecules start sticking to the condensation nuclei, they have a chance to rearrange themselves into the precise arrangement that we call ice. However, recall what we said earlier about how ice can only form when water molecules stack in precise geometric arrangements. The reality is that floating particles come in all types of random, irregular shapes, and this makes it extremely difficult for water molecules to stack in precise arrangements that produce ice crystals. Ultimately, ice crystals can form around irregular particles like dust and soot, but not in the sheer numbers needed to produce heavy rain or snow. So this is where another agent enters the picture. So we never think about this, but plant leaves are one of the largest surfaces on Earth, and every leaf is covered in 1 to 10 million bacteria. And what happens is that in the wind or on hot days, countless bacteria are lifted off leaves and carried upwards into the atmosphere, where these microscopic organisms would be trapped forever, except they've evolved a nifty trick for getting back to Earth. The most abundant and well-studied of these bacteria is a species known as Pseudomonas syringae that is found on plants everywhere in the world. And these bacteria are well known for coating their outer shells with a protein that is precisely patterned to grab and stack water molecules in the exact arrangement that creates ice. What this means is that ice formation is so readily facilitated that these bacteria can create ice crystals in turbulent conditions or at temperatures approaching 32 degrees Fahrenheit. So remember what we said earlier about ice crystals needing either stable conditions or extremely low temperatures. Clouds are always swirling and moving, and they are often fairly warm. So the likelihood of ice crystals forming in clouds is greatly enhanced by the presence of these so-called ice nucleating bacteria. In fact, a significant portion of all the snow and rain, which is what happens when ice crystals fall through the warm air on Earth, is created by bacteria. And here's one more piece to this story. Why would bacteria evolve the ability to trigger ice formation in the first place? So remember that these bacteria live on leaf surfaces. And leaf surfaces are a hard place to live because you're fully exposed to extreme conditions and intense solar energy. Leaves also protect themselves with tough cell membranes, so there's no food for bacteria. However, in an evolutionary stroke of genius, these bacteria have evolved the ability to create ice at temperatures where ice would never otherwise form. And then they use these ice crystals to cut open the membranes of cell leaves and access their nutritious contents. Farmers and horticulturalists know this phenomenon as frost damage, and it happens all the time. And then, just as remarkable, bacteria that are trapped in the atmosphere use this same ice forming mechanism to create ice crystals and be carried back to Earth as rain or snow. In fact, the bacteria are delivering the same water that grows the plants that they eat, and in the process, they create all life on Earth. So thank you, bacteria.